In this video, we are going to talk about private module fragments. And this is a feature C++ 20 modules provide to improve on your compilation speeds. With this feature, you can keep the declaration separate from the implementation in a single file, but things have to be living in a single file. This is a requirement to have a private module fragment. One of the big benefits of this is that changes in the private fragment don't trigger recompilation of translation units that import the module. And you can see that this is going to improve compilation speeds. If you have hundreds of files that depend on a module and you change something in the interface, all these things that depend on the module are going to be recompiled. But if your implementations are stored in a private fragment, you won't be triggering recompilation unnecessarily. Let's look at how you can do this syntactically. So we have a module here and it is exporting a namespace. We have a double function, but the implementation of this double function lives in a private fragment of this module. You mark it as a private fragment by using module :private and using a semicolon like this. And anything that is below this line, line 8, is going to be part of your private fragment. This is really how you do this. Once you have this, you get to use your module in the main CPP file like you use any other module. You see we can use the add function, but later on, if we happen to need to change things in this implementation here, these changes won't retrigger compilation of other modules that are importing this module. We will only recompile this module, and this is going to improve on your compilation speeds. This is something you can take advantage of if you need it for your project. For now, we're going to head over to our IDE and see this in action. This is the project for the 8 private module fragment. And we can hop over to GitHub to see what we have in there. We have a math interface file. If we look at it, it is just going to be containing the code we saw in the slides. So let's copy it and create the file in our IDE here. Let's add the new file. Let's add it again. And it is going to be math.ixx like we always do. And we can put in the content by pasting here. Okay, we have the file and we can grab the main CPP file. So let's copy it and come back to our IDE and put it in. And we can enable C++ 20 by coming to properties, choosing language, choosing C++ 20 here, and going up to general and choosing scan sources from module dependencies. This is something we need to do in this IDE. Once we do that, we can try to build. We won't see any new thing really. The only requirement is that build, but compilers will notice that we are using a private fragment and they will know that if we change something here, we won't have to recompile things that depend on this math module of ours. And this is something you can take advantage of. One thing I want you to know is that the code compiles and links with Visual C++. It doesn't seem to work with G++ yet. This is what I have seen from my experiments, and I will show you in a minute. And it works well with Clang 18. So this is something you can take. So if you want to see this running, Clang 18 is the way to go. I don't remember if it actually works with Clang 16, but we can try this out. We are here, so we will try in a minute. Okay, to really have a good experience with this, let's go back and grab our README file and look at it. You can look at it here in the Git repository, but I would like for it to be available so that you can read it when you are going through this. So I am going to put this in the same folder as our current project. We can get where the current project is stored by coming in the IDE, right-clicking, and do we have the option to see where it is stored on my drive? I don't think we do, so we can go where it is stored manually. I am going to open a new Explorer window. I am going to go to the location where my project is stored and go to modules and go to private module fragment and put in my README file here. Once I put it there, I have the option to hit Control O and open this file here, and we can see it inside our IDE. This is going to be much easier. Okay, we have just compiled this in Visual C++, but we can try to use G++. And you see that we have a marker here saying that this is going to fail, but let's try this so that you can see this with your own eyes. Make sure you are in the current project location. So this is the current project location. Let's try to compile the IO stream header unit, copy and put this in place. It is going to go through. But if we try to compile code that uses private module fragments with G++, it is going to say unimplemented private module fragment module private. So my guess is that G++ doesn't support this yet, and we won't go any further with GCC. So let's stop here and remove any junk that was left in by GCC, remove the PCM header, PCM file, I should say, and we can try Clang. Let's go to our terminal because that's where we use Clang, command prompt, I should say. Let's try to compile the IO stream header. So let's compile this into a header unit. It is going to go through. We can try to compile the module file into a PCM file. This is going to go through. Let's try to compile the main object file, and this may go through. It is going to go through. Let's try to compile the object file for our module. It is going to go through, and we can generate the rooster binary. Let's compile, and it is going to go through. If we do dir, we should have our rooster binary right here, and we can try to run it by saying rooster, and it is going to do whatever is done in our main CPP file. In this case, you can see that Clang can do something that GCC can't do, and this is what you get by trying all these compilers. You get to know the intricacies of what compiler supports which feature. Let's try this with Clang 18 inside our Docker container. Because we have access to it, we have to try it. But before we do, let's remove any junk that was left in by GCC or by Clang on Windows. We need to remove the PCM files, remove the object files, and remove the rooster binary. Let's try to run with Clang. So copy the file, the command, I should say, put it in. This is going to generate our header unit. Copy the command to compile the PCM file for the math module. Put it in. It is going to go through. And we grab the command to compile the main object file, copy it, put it in place, and it is going to go through. We grab the command to compile the object file for our module, copy it, put it in place, it is going to go through. And we can grab the command to compile the final binary by linking everything together. So let's do that and hit enter. If we do lsalh, we will see all the files, including the rooster binary, and we can run it by hitting rooster like this, and it is going to give us the output. This is really all I had to share in this video, showing you how you can use the private module fragment feature. It works on Visual C++ and Clang, as we have seen, but GCC seems not to be ready for this yet. Maybe if you are watching this in the future, it is going to support it, but this is the situation we have right now. I am stopping here in this video, and I will see you in the next one.